Welcome back. In the last session, we covered problem number 15 from subject-wise test 2 problems. Now let's continue and then solve for common data problem having 2 bits 16 and 17. Common data problem. (16) and 17. Circuit is given. A regulated power supply shown in figure has unregulated input, which is 15 volts, and generates regulated output voltage. Okay, now the circuit is this is the load 10 ohm and this is what is Vout, and the output of this, the op amp is driving your transistor. I think we had seen this circuit already. Okay, this is 12 kilo ohm, 24 kilo ohm, and this is what is having 1K and China diode under breakdown. This is what is having 6 volt, 1K, and this is what is 15 volt unregulated supply. Okay, this is what your transistor Q, and this is what is plus minus. Okay, now problem number 16. The problem number 16 is, what is that? The power dissipation across the transistor. The power dissipation across the transistor is. That is what is problem number 16. Okay. What is problem number 17? If the unregulated voltage increases by 20%, then power dissipation across the transistor. That is what we need to find. Okay. Fine. Negative feedback or positive feedback? Surely it will be negative feedback. Then only it is called as a regulator, right? But how to find? If you open the loop, increase the voltage, base voltage is increasing, base current is increasing, collector current is increasing, emitter current is increasing, the output voltage is increasing, beta V0 is increasing, minus is increasing, this will decrease. Therefore, it is opposite, negative feedback, don't need to say anything. If op amp is configured in negative feedback, then we can use virtual ground concept. Therefore, according to virtual ground concept, when I say this is what it is, then what is this? When you say this is what your V out, this is nothing but your beta into V out. This is nothing but your sampling network. Therefore, beta into V out will be equal to what? That will be equal to your 6 volt. Because Vout is not given, which we need to find. That we can find, right? Fine. Now, first of all, what is our PQ? PQ, power dissipation across the transistor, is defined as VCE. This is what your collector and this is what your emitter. And the current which is what is flowing through is, let us say this is IC. The same current is flowing, right? This is IE. IE is approximately equal to IC. Now you can neglect the current which is flowing through 12K and then 24K. Why? The 12K, 24K, this is 36K in parallel to 10 ohm. The current which is flowing through this is in the order of milliampere, but the current which is flowing through 10 ohm is in the order of ampere. The milliampere of current can be neglected with respect to ampere of current. Or 10 ohm in parallel to 36K is approximately equal to 10 ohm. Remember, this is what we need. Intentionally the 12K, 24K they are chosen such that the current which is what is taken by the beta network will be very, very, very small, because the job of beta network is to sample your output voltage and feed to your op amp. Therefore, the same current is flowing and this is what your load current. Therefore, this is nothing but your IE. IE is nothing but your load current. Therefore, the same is flowing. Therefore, let us say this is what your load current, this is your IL. Okay. Therefore, now what is this? This is nothing but your VCE into IC or IE. Therefore, what is your VCE? Voltage at collector minus voltage at emitter. IC is nothing but your load current IL. Therefore, what is voltage at collector? That is nothing but your input voltage, unregulated supply. VE, voltage at emitter, is nothing but your output voltage, V out, and this is nothing but your IL. What is IL? V out divided by 10 ohm. Or directly find IL, then we can substitute here. This is IL. This is equation 1. If you find V out, problem is over. To find V out. How will you find V out? We got already, right? We know that because virtual current concept, this is having 6 volt. Surely your op amp is trying to track to get here 6 volt. Therefore, when you say this is 6 volt, this is also 6 volt. Therefore, beta V out is equal to 6 volt. Beta into V out is equal to 6 volt. Then what is beta? 24k divided by 24k plus 12k, 36k into V out is equal to 6. K will be cancelled. Then 6 4 jar, 6 9 jar, right? Is it correct? 4 6 jar, 4 9 jar. This is 6. Okay. 4 6 jar. Then 6 6 will be cancelled. Therefore, what is V out? V out is equal to 9 volt. This is what your regulator supply. Regulated output voltage. Regulated output voltage. Therefore, now tell me, then what is your IL? IL is nothing but V out divided by your V out divided by 10, which is nothing but 0.9 ampere, which is 900 milliampere. That's why we neglected this current. Okay. Then 1 implies, what is the power dissipation across the transistor is equal to 15 minus 9 into 0.9, which is 6 into 0.9, which is 5.4 watt. Therefore, what is the answer? C. Answer is C. Okay. Then we'll see problem number 17. What is problem number 17? Problem number 17. What is it saying? If the unregulated voltage increases by 20%, therefore, if your input, right, what is that? Voltage at collector, unregulated voltage. If that is what is increasing by 15 plus 20% of 15, that is increased by 20%. Then it is nothing but 15 plus 20% of 15 is nothing but 3, which is nothing but 18. Therefore, your input is becoming 18. Then what is your new power dissipation? Is equal to VCE into IC. What is VCE? Voltage at collector minus voltage at emitter into the load current. Okay. Therefore, what is your PQ? New power. Voltage at collector is nothing but 18. Voltage at emitter, because this is regulated, your feedback will control such that your output is not changing even though your input is changing. That is 9 into your load is nothing but 0.9. It is line regulation. Therefore, 9 into 0.9, 8.1 watt. Then if you want to know that change in the power, right, is nothing but, percentage change in power. Percentage change in power is equal to delta PQ divided by PQ into 100. What is delta PQ? 8.1 watt minus 5.4 watt divided by 5.4 into 100. 5.4 minus 8.1, 2.7 divided by 5.4 into 100, which is nothing but 50% increase. Therefore, your power dissipation across the transistor is increased by 50%. Therefore, what is the answer? Increases by 50%. Answer is B. Okay, take it, then we will solve remaining problems. I will give you 1.5 minute time and try to note. Then we will see problem number 18. Done, right? Then we will see problem number 18. 18 is straightforward. The oscillator circuit shown figure has an ideal inverting amplifier. Its frequency of oscillation. Basically, this is RC phase shift oscillator. This is inverting amplifier. That is what is told. And the circuit is they're asking F0. See, he told that this is inverting amplifier. Then this is nothing but your beta network. It should give 180 degrees. The frequency at which the total loop phase shift is 0 degrees or multiple of 2 pi. That is what is going to give you the frequency of oscillations. That is what is Barkhousel criteria. And to get sustained oscillations, the total loop gain must be equal to unity. A into beta should be equal to 1. And then if you solve, you'll get this is nothing but RC phase shift oscillator. This is RC phase shift oscillator. If RC phase shift oscillator, then your resonant frequency is equal to 1 by 2 pi RC root 6. If it is Wien bridge oscillator, 1 by 2 pi RC only. Therefore, what is the answer? Answer is A. Done. Problem number 19. Value of R in the oscillator shown. So chosen that it just oscillates at an angular frequency of omega. The value of omega, okay, R is chosen, okay. R, the value of R, okay, and is asking indirectly resonant frequency omega naught and the value of R such that it will oscillate. The circuit is, this is what is our minus plus this is 5 kilo ohm, this is 100 kilo ohm, okay. Now indirectly we need to find the resonant frequency, and to get sustained oscillations, what is the value of R? That is what we need to calculate, okay. Now can I write this, can I say this is nothing but your open loop amplifier? If I write this is nothing but your minus plus, okay, This is nothing but this is your V naught, right? And this is 100K, and this is 5 kilo ohm, right? If you observe clearly, this is nothing but what? This is what is your beta network. This is nothing but your beta network, and this is nothing but your open loop amplifier. This is nothing but your open loop amplifier. Therefore, if you see, it is indirectly, it is nothing but your open loop amplifier A, and there is a beta network beta, then output is connected like this. Okay, and remember, this is non-inverting amplifier. This is giving 0 degrees phase shift. Then therefore we need 0 degrees phase shift. Then only you will get oscillations according to Barkhausen criteria. If this is giving 0 degrees phase shift, because this is non-inverting amplifier, right? And this is what your beta. If this is also giving 0 degrees, then only at what frequency you are getting total loop phase shift. That is what is your resonant frequency. That is what we need to find, right? Therefore, what is your beta network? Beta is nothing but what? When you say this is what is your V naught, and this is what your feedback Vs. Beta is nothing but Vf by V naught. That is what we need to find. From this is what is nothing but your beta into V naught. Your Vf is equal to beta into V naught. Therefore, beta is equal to Vf by V naught. Therefore, how to find beta? Beta is nothing but Vf by V naught. How to find? It is like Z2 divided by Z1. You can do like that also, or you apply nodal analysis. When you apply nodal analysis, you will get the answer. Therefore, tell me, when I say this is what is Vf, right? Vf minus V naught divided by R plus Vf minus 0 divided by 1K plus Vf minus 0 divided by S into L plus Vf minus 0 divided by 1 by Sc is equal to 0. If you take Vf common, you will get 1 by R plus 1 by 1K plus 1 by SL plus Sc is equal to V naught divided by R, right? Therefore, if you take Vf here, you will get 1 by R plus 1 by 1K, right? Plus Vf, if you take S is equal to j omega, you will get Vf into, okay, completely you can take, this is what is real part, then imaginary part, if you take j, you will get omega c minus 1 by omega L is equal to V naught by R, right? Therefore, what is Vf by V naught? Therefore, beta is equal to Vf divided by V naught. What is your beta? Beta is nothing but Vf divided by V naught. Therefore, what is that value? This will come to numerator. Therefore, 1 divided by R into 1 by R plus 1 by 1K plus J into omega C minus 1 by omega C. Right? Therefore, if you do this, what we want to get now, what is your resonant frequency? Therefore, to find F naught or omega naught, right? When the imaginary term is 0, then only it is giving 0 degrees phase shift, right? Therefore, what is the condition? Omega naught C 1 divided by omega naught 1 by omega L, okay? Omega naught L is equal to 0. Therefore, if you do, omega naught is nothing but 1 by root over LC. That is what your resonant frequency. Then you know already L and C. Therefore, what is that? If you do 1 divided by L, 10 milli 10 to the power of minus 3. What is C value? 0.01, 10 to the power of minus 2 into 10 to the power of minus 6. If you do, what you get radians per second? Then minus 3, minus 11, minus 10, 10 to the power of 5. Therefore, you will get 10 to the power of 5 radians per second. This is what is our omega naught. That is the first one. Therefore, what is the answer? Your answer is, we have two answers, either A or D. Now we need to find the R value, right? Once for this value. Therefore, now tell me, at F is equal to F naught, at omega is equal to omega naught, what is your beta? Your beta is what? Your beta is 1 by R, right? 1 divided by R into R plus R by 1K. This is what is your beta. To get sustained oscillations, to get, according to Barkhousam criteria, to get sustained oscillations, your A into beta should be equal to 1. You call this as equation 1. But what is your A? Your A is nothing but 1 plus R2 by R1. 1 plus, what is R2? 100K. What is R1? 5K. KK will be cancelled, it is 21. Therefore, what is your beta? Therefore, your beta is equal to 1 by A or 1 by 21. This is what you can call it as star. This is what your A. You can do it before. Then star beta. Then if you do it, what you get? 1 by 21 is equal to 1 divided by 1 plus R by 1K. Then 1 plus R by 1K is equal to 21. Then R by 1K is equal to 20. Then R is equal to 20 kilo ohm. What is the answer? 2 into 10 to the power of 4. Therefore, answer is A. Answer is A. I hope everybody understood. Did you understand the procedure? I think this is what we used for Barkhousam criteria, right? According to Barkhousam criteria, there are two principles. The total loop phase shift must be equal to 0 degrees or multiple of 2 pi to get frequency of oscillations. To get sustained oscillations, the total loop gain must be equal to unity. Out of these two, the primary condition is the total loop phase shift must be equal to 0 degrees. Then only you will get oscillations. Once you get oscillations, whether they are critically damped oscillations, sustained oscillations, over damped oscillations, under damped oscillations, that depends on the total loop gain. Okay, that's why the first step, what we did, we calculated the beta value, then we calculate the resonant frequency. For what condition your beta will be giving 0 degrees phase shift, because we know that your A is giving 0 degrees phase shift because this is non-inverting amplifier. Then we got the condition, we got the resonant frequency, we substituted it, we got it. Now the next step is to get sustained oscillations, your loop gain must be equal to unity, then beta is equal to 1 by A, we know already A, then you got it, then to get sustained oscillations, what is the value of R, we calculated and then we got 20 kilo ohm. That is the procedure. Okay. Done. After this, the final problem for the test 2. Then with that it is done. I'll give you 1.5 minute time, then we will see that. Okay. Done. Now the last problem. Consider the Smith-Tregber circuit shown below. A triangular wave goes from +12 to -12 to +12 is applied to the inverting input of op amp. Assume that the output of op amp swings from +15 to -15. The voltage at the non-inverting input switches between. Okay. The problem is minus plus. This is what your VI. Okay. This is what is 10K. Minus 15. Now this is what is, this is your V0. Now this is what is plus 15. Okay, actually this is what directly we can give. This is what is plus 15. And now this is minus 15. This is 10 kilo ohm. This is also 10 kilo ohm. This is also 10 kilo ohm. Okay, this is what. Now a triangular wave. For a triangular wave is given at the input. This is plus 12 and then minus 12. This is what is there. Okay. If this is what is applied, fine. Now is asking what is the voltage at non-inverting input. Non-inverting means that is asking the voltage at the non-inverting input switches between what and what. If output is switching between plus 15 to minus 15, and if input is having triangular wave of plus 12 to minus 12, then what is the voltage at this point? Let us say this is what your VA, that is what is switching. If input is switching from plus 12 to minus 12, if output is switching from plus 15 to minus 15, then what is the voltage at non-inverting terminal that is switching? Okay. Before all those things, is it negative feedback or positive feedback? See, your input is applied at minus, but your output is sampled, and remember this is what, right? Maybe for your understanding purpose, can I draw the same circuit like this? This is your VI, right? Now this is your V0. This is minus 15. Now this is plus 15. 10K, 10K, 10K. Everything is 10K. Can I write like this? And it is having power supply plus or minus 15 volt. Right? Can I write like this? Yes, I can write, right? This 10K is 15. 10K is 15. 10K is minus 15. And then this is 10K. Tell me what type of feedback. This is easy to understand. What type of feedback it is? Can I say this is nothing but your positive feedback? Remember, this is in positive feedback. If this is in positive feedback, virtual ground concept is not valid. Then we have to treat it like a comparator. Now your op amp is a comparator. If op amp is a comparator, then what is the procedure? I already gave the procedure. What is the procedure? If the problem is related to positive feedback, then definitely it is a comparator. Then definitely, if you see here, your V0 will be, you can start with, right? Your V0 will have either plus 15 or minus 15. You can start with any voltage, okay? Then if you ask, let us say, you can start with what? You can start, let us say V0 is equal to plus 15. When V0 is equal to plus 15, okay? This is what is your circuit, minus, plus, and this is your VI. We are starting either plus 15 or minus 15. I am starting with plus 15. Then we will see. We will analyze the circuit. Okay. This is what is our 10K, and this is 15 volt. This is minus 15 volt. Now this is what is your V0. Now what is your V0? Your V0 is 15. This is 10K. This is also 10K. This is 10K. Okay. Now let's find what is VA. You will understand. Let's find first what is VA. Okay. Now apply nodal analysis. You will get the answer. Right. When you apply nodal analysis, VA minus 15. VA minus 15 divided by 10K plus VA minus of 15 divided by 10K plus VA minus V0. What is V0? 15 only, divided by 10K is equal to 0. Then 10K will be cancelled. Then VA minus 15 plus VA minus into minus plus 15 plus VA minus 15 is equal to 0. Then tell me VA plus VA plus VA. 3 VA minus 15 plus 15 will be cancelled is equal to 15. Then what is your VA? VA is equal to 5 volt. What does it mean? Therefore, now what is your VA if this is what is 5? Therefore, what does it mean? If your VI is less than 5 volt, then this is 5, this is less than 5, your output is 15. Fine. When you are changing your VI from minus infinity to plus infinity, okay, then let me draw the transfer curve. If I draw the transfer curve, this is your VI and this is what your V0. What is the break point? The break point is 5 volt. Okay. When your VI is less than 5, when VI is less than 5, which is more? Plus is more or minus is more? If it is less than 5, plus is more than plus VSAT. If it is less than this, this is what is our output. More than 5 volt, it will be minus 15. This is plus 15, minus 15. Therefore, the arrow is indicating the direction. When input is changing from minus infinity to plus infinity, you will get this. Okay. Fine. Now, case 2. When output is switched from plus 15 to minus 15. Let us say output change from plus 15 to minus 15. Now, come back. When input is changing, see, I am not responding to the triangular wave. I will respond to triangular wave later. First of all, I am trying to plot the transfer curve. Once you know the transfer curve, then we can respond to triangular wave also. Okay. Now, case 2. When output is minus 15. When output is minus 15, then what you get? The same. Now, if you take the op amp minus plus, now this is your VI. Now, this is what we have. This is minus 15 and this is plus 15. Your V0, right, is equal to minus 15. This is 10K, 10K, 10K. And this is what is your VA. This is what we need to find. Let us say, let's find VA, right, when VA is 15. Again, apply nodal analysis, you will get the answer. VA minus 15, VA minus 15 divided by 10K plus VA minus of minus 15 divided by 10K plus VA minus of minus 15. Actually, I would have taken V0, then we would have substituted it. Anyway, it's fine. Minus 15 divided by 10K is equal to 0. 10K will be cancelled. 3 VA, 15 will be cancelled, plus 15. Therefore, 3 VA is equal to minus 15. 3 VA is equal to minus 15. Therefore, what is VA? Minus 5. Therefore, what is that? This is what is minus 5. When output is minus 15, you are switching, non-inverting switching voltage is minus 5. Therefore, if you draw the transfer curve, this is what is your VI and this is what your V0. Okay. Therefore, now tell me what is this break point? Now the break point is minus 5. Your break point is minus 5. Therefore, tell me if your VI is more than minus 5, let us say 0, which is more? Minus is more. then it will be minus. Okay, more than -5, then it is minus 15. If it is less than -5, let us say -6, which is more? Plus is more. Therefore, this is what is our curve. Arrow is indicating when VI is changing from this. This is what is -15 to +15. If you combine these two, what you will get? If you combine those two, you will get a transfer curve like this. This is what is 5 volt. This is your VI, and this is what is your V0, and you will get another curve. Therefore, this is what is the arrow, and this is what is -5. Okay, this is what is your hysteresis curve. Okay, now you can respond to your actual input. Okay, if you respond to actual input, what you get? Now if you respond to actual input, let us say this is what your actual input, +12 and then -12, +12, -12. This is one cycle is enough. This is +12 and then -12. Okay, therefore tell me, this is what we want to find, output voltage. Therefore now tell me, when input is increasing forward direction, what is the switching point? 5. Another direction, switching point is -5. This is 5 volt and -5 volt. Therefore now tell me, less than 5 it is +15, less than 5 it is +15, more than 5 it is -15. Now reverse direction, now the switching point is not 5. When input is decreasing, now the switching point is -5, therefore -5 till this point, therefore it will be like this. This will be continued. Okay, therefore this is what is called UTP, upper triggering point, and this is what is LTP, lower triggering point. Actually this is what you are seeing at non-inverting terminal, that is what is switching between 5 -5, 5 -5, when output is switching from +15 to -15. Okay, this is what your V0. Remember, this is what is hysteresis voltage. Hysteresis voltage is nothing but UTP minus LTP. The switching point is not same. With respect to direction, the switching point is defined. Okay. Therefore, what is the answer? Your answer is C, -5 and then +5. Okay. Answer is C. See, we have seen all these problems, but this is a different problem, but related to network analysis only. With this I can say the problems are over. Subject wise, test 2 as well. Okay, thank you so much. Okay, bye.